Hey everyone, I'm just here to help you review some of the half-life problems that we've been going over. So I'm using a little webcam here, and I'm just going to go through two problems for you just to remind you what they look like, and hopefully this will be helpful for you. So our first problem is this. You have a 200-gram sample of radioactive substance X. I didn't tell you what it is, it doesn't matter. Its half-life is 35 years. How much will remain in 140 years? So there's a number of pieces of important information here. The first one is that we have 200 grams of the sample. The next one is that its half-life is 35 years. And we want to know how much is going to remain in 140 years. So we're going to start with, woohoo, that just made a funny little noise, or motion. Anyway, so we're going to start with 200 grams of X. Oh, sorry. We're going to start by figuring out how many half-lives X is going to go through in 140 years. So we know if one half-life equals 35 years, how many half-lives equal 140 years? And you can just use division to figure out that it's 4 half-lives. So I just divided 140 by 35 and I got 4. So I need to figure out how much is going to be left after 4 half-lives. And I do know you can do this in your head. I'm very aware of that. This is just simple division, and this is just simple dividing by 2. But we need to make sure that we're showing the actual process of radioactive decay. So here we are. We've got 200 grams of X, and it needs to go through 4 different half-lives. So after 1 half-life, which I'm going to label here with my arrow, or you could label it as 35 years. That'd be fine. I know that I have 100 grams of X left. Then after a second half-life, or I'm going to put 1 extra half-life, or 70 years later, I've got 50 grams of X left. This keeps going through a half-life each time. Then after 105 years, or another half-life, sorry, there's still 1 half-life. Sorry, on this side I'm just counting 1 half-life. I can't write 1 half-life though. There we go. Then I have 25 grams of X left. Oops, I'm going off the page. And then finally, after 140 years, I have 12.5 grams of X left. Okay, so here, this shows the process that X has gone through, both in terms of half-lives, but also in terms of years. So you can choose either way to do this. In theory, I didn't even actually have to do this math up here. I could have just gone through and counted the years until I got to my endpoint of 140 years. I just kind of wanted to double check and make sure. So I think that should be helpful. So that's our first problem. Another kind of problem that you're going to see, although this is very similar, is this type. So this says plutonium-238 is a radioisotope that decays into uranium-235. Its half-life is 24,000 years. And first you're asked to model the decay of plutonium-238. So that was something we went over in class recently. So this is our first thing we're going to do is model the decay. And I know if I want to do that, that just means showing what it started out as and what it ended up as and what its process was. So here I'm going to look at the nucleus of plutonium-238. There's that. And inside that nucleus, I know I have, I don't have my periodic table. Hold one sec. Let me grab my periodic table. Where are you, periodic tables? Here we go. And I'm back. Okay, plutonium, I know. Its periodic, its atomic number is 94. I looked here, obviously, plutonium down here, 94. So that's great. So I know it, because of that, I know it has 94 protons. And I also know, because its atomic number is 238, that it's going to have 238 minus 94, which gives me 144. Does that make sense? 144 neutrons. Great, that's what we're starting with. But that decays. Lets off energy. Right? This is happening. And over here is my product, which is the nucleus. I'm going to show that of uranium-235, right? So here's that. So uranium, back to my periodic table, I see has 92, where is it? Down here, uranium has 92 protons, which I know because of its atomic number. So 92 protons. And I know that it has what would it have? So I'm just going to do math because I don't want to do this wrong in a video. So 143 neutrons. Okay, so here I can see that when plutonium decays into uranium, it loses 2 protons and loses 1 neutron. Great. Or plutonium-238, sorry, decays into uranium-235. These particular types of molecules have lots, of elements have lots of different isotopes. Okay, finally, we're going to look at this last type of problem, which was one of the ones that was on the formative assessment that a few of you had a problem with. And that's if you have a sample that is 60 grams uranium-235 and 20 grams plutonium-238, so back up to this problem, how old is your sample? Well, I have a half-life up here. And now I want to know, how old is my sample? Well, first thing I need to look at when looking at this kind of problem is how big is my sample in general? So I know that at this point in time, I have 60 grams of one of the substances and 20 grams of the other. So this is what it started out as, and this is what it decayed into. So I know total, because I've got the 60 and the 20, that I have an 80-gram sample. So that means that when we started out, my plutonium-238 at half-life 0, I had, let me make my whole chart here, I had 80 grams of plutonium-238 and 0 grams of uranium-235. After 1 half-life, I had 40 grams of plutonium-238 and 40 grams of uranium-235. After 2 half-lives, I'm just putting this in here to label it, I had 20 grams of plutonium-238 and 60 grams of uranium-235, which actually is where I wanted to be. These match my numbers up here. So I know I've gone through 2 half-lives. So 2 half-lives for this particular substance, lives, equals 2,400, because that's 1 half-life, times 2, or 48,000 years. Okay, so that is how you would solve this kind of problem. This is essentially the sort of difficulty that you'll need to be able to do for the assessment that we're doing this week. Hopefully this was helpful for you. It's obviously, if you have any questions about the problems that I gave you, you can let me know. Okay, great. Take care.